Trigonometry, section 2.2. Let's see if we can get through this stuff. These are trigonometric functions of non-acute angles. Remember we looked at points in the plane. This point xy and its distance from the origin, which is r. That can give us a right triangle, and we can use this angle with opposite and adjacent and hypotenuse. We can use the x, y, and the r. So we can reduce some of our values to just a few. That's where that one sort of a table of ideas came up. Tangent theta is sine theta over the cosine of theta. The sine of theta is the square root of 0, 1, 2, 3, 4 over 2. The cosine is 4, 3, 2, 1, 0 over 2. This is for 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. But these values work for more than just this first quadrant. If we can show that this makes a triangle that looks exactly the same, except maybe in a different quadrant, if this is xy, this could be negative x, positive y, but r is still the same. The values are the same, it's just that x would be negative and y would be positive. But as far as the values are concerned, they're all exactly the same. We just have to figure out what the trig function, positive and negative trig functions are for this angle that is not acute, that large angle, greater than something that's between 0 and 90. But we can use the acute angle here, just as we did this one in the first quadrant. So what we need to do is be able to talk about reference angles, because it doesn't matter if we have the same x and y values, absolute value of the x and y, and r is always positive. We're going to have points that are going to be the same values and just change the plus and minus sign. So let's take a look at some examples here. If we look at 218 degrees, what is the reference angle for 218 degrees? Well, notice we're always measuring between the x-axis and that terminal side. Doesn't matter if it's a positive x-axis and negative x-axis. Where's 218 degrees? That's in the third quadrant. So we have a triangle like this in the third quadrant. Now both x and y are negative in this quadrant. R is always positive, but it's still the same value as anything over here in the first quadrant with that same theta. We'll call this, I guess, theta prime, this theta. Because this is the same x and y, it's just that they're both positive. R is always positive. And all we need to do is say, well, heck, in the third quadrant, the trig functions, some are positive, some are negative, and we know how to determine that. So, what is this angle theta prime, this little bitty angle? Well, if this is 180 degrees, and this one all the way around is 218, then how far have you gone past that 180 degrees? Well, subtract 8 minus 0 and 11 minus 8. So you've got 38 degrees beyond. So 38 degrees is the reference angle. The trig values for the reference angle, 38 degrees, will be exactly as the ones for 218, except some of these will be negative. These are always positive. So a reference angle is always positive. You don't care which direction you're measuring, but you're using a small angle, an angle between 0 and 90, to figure this stuff out. So what are the reference angles for, say, 243 degrees? Well, let's see. I've got to go around past 180. How far? 3 and 14 minus 8 is 6. So 63 degrees is its reference angle. What is the reference angle for 52 degrees? Well, 52 degrees is in the first quadrant. It doesn't go further than 90 degrees, so 52 degrees is its own reference angle. What is the reference angle of 125 degrees? Well, 125 is in the second quadrant. Let's draw a new picture. This is the 125 degrees. How far does it take me to get to 180? So sometimes you're going to subtract 180 from the angle. Sometimes you're going to subtract the angle from 180. So it's 180 degrees minus 125. 10 minus 5 is 5. 7 minus 2 is 5. So 55 degrees is that reference angle. Depends upon which quadrant you're in, but I think drawing a picture, which gives you a step also. What about 330 degrees? Well, let's see. Here's the 90. Let's go around the circle. 90, 180, 270, 330, someplace here in the fourth quadrant. So now I've got to find out how far till I get to 360. So now you take and subtract the angle from 360 degrees, which gives us 30 degrees, which means we can go back up here and use these values for that. So 330 degrees will give you the same values with only the difference in plus or minus signs as this 30 degree angle here. Does this make sense? Okay, let's do some examples instead of just talking. Number 36, this is really on page 59. It asks, find the exact values of the 6 trig functions for each angle. Rationalize any denominators. So, number 36 is a negative 2,205 degrees. We just have to find the reference angle. Let's see. 2,205 divided by 360. Well, we can use our calculator a little bit for this. Take 2,205 and divide by 360. You get 6.125. What does that mean? That means gone around the circle 1, 2, 3, 4, 5, 6, and then you've gone around the circle 0.125. Well, let's first of all get rid of that 6. So subtract 6 from that. We just have the 0.125. How far is that? Well, it's 0.125 of the circle. Of usually means multiplication, and the circle is 360 degrees. So we're going to go another 45 degrees. That is the reference angle. So one way to do this is, now, I'm sorry, and I made a mistake here. That's a negative, right? So it's not going counterclockwise, it's going clockwise. 1, 2, 3, 4, 5, 6, and we'd end up right here, 45 degrees. But it really doesn't matter in this case, but it's really the wrong angle that I was looking at, because it's always, the reference angle is always positive. You just have to know that you'll be in quadrant 4 when you apply all the plus or minus signs when you're done. Anyway, take the angle, if it's really big, divide by 360. The whole number tells you how many times you go around the circle. It's subtract that because you just need the decimal. That's the fraction you went around the circle again. And then you can draw your picture and figure out the, I guess, rest of the one, in this case 45. So I'm really looking at, when I look at the sine of a negative 2,205 degrees, I'm really looking at the sine of 45. Remember that? The tangent is the sine over the cosine. This is 0, 1, 2, 3, 4 over 2. This is 4, 3, 2, 1, 0 over 2. Now I got to use something that's a little sharper. For 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay, I should write that on a little card so I can just keep referencing it. But remember, this is really just 45 degrees. So what is the sine of 45 degrees? It's the square root of 2 over 2. The only thing I have to worry about is, what is the plus or minus sign of the sine function in the fourth quadrant? Remember, this is plus and minus. The y is negative, so the sine is negative. The cosine of a negative 2,205 degrees. Now I need the cosine of 45, well, that's also square root of 2 over 2. But the cosine is positive in the fourth quadrant. All seniors take Cal for C being for cosine and its reciprocal, the secant. How about the tangent of a negative 2,205 degrees? Well, see, the tangent is the sine over the cosine, square root of 2 over 2 over the square root of 2 over 2, which is just 1. In that quadrant, is this plus or minus 1? It's a minus 1. The cosine and its sort of cousin secant are positive in the fourth quadrant. Everybody else is negative. The cotangent of a negative 2,205 degrees, reciprocal of a negative 1 is negative 1. Let me go here so I can save a little bit of room. The cosecant of a negative 2,205 degrees, reciprocal of the sine, which is a negative 2 over the square root of 2, and the secant of a negative 2,205 degrees is a positive 2 over the square root of 2. Now we're supposed to rationalize denominators. So multiply by the square root of 2, both numerator and denominator, and we get finally 2 times the square root of 2 over 2. Well, those 2's cancel. Square root of 2. But this is negative. Don't forget to bring that along. And the secant is positive because both the cosine and secant are positive in that quadrant. Okay, how about number 44? Number 44 is asking the value of each expression. They just want cotangent, 2,280 degrees. Okay, let's see. How many times we go around the circle? Let's see. 2,280 divided by 360 is 6.33333. Repeating. That's how many times, right? Let's not say that's equal. So subtract the 6 and you get 1/3, right? Subtract the 6, let's see, times the 360. Subtract the whole number, multiply by 360. You get 120. Okay, that's important. 120 is in quadrant 2. That is not the reference angle. The reference angle is 60, because that's what it takes for this 120 degrees to get to this 180. So the reference angle is 60. Now, so this cotangent is really equal to 1 over the tangent, reciprocal of this 60 degrees in the second quadrant. And the tangent of 60, let's see. So it's 1 over, the tangent is sine of 60, square root of 3 over 2, over the cosine of 60 is 1/2. Well, we want the cotangent, so we need the reciprocal of that. So this is really 1/2 over square root of 3 over 2. And when you divide by a fraction, you really multiply by the reciprocal, which is 2 over the square root of 3. These two cancel, and you get 1 over the square root of 3. Oh my gosh, we need to rationalize the denominator. Multiply both numerator and denominator by the square root of 3, and you get the square root of 3 over 3. But don't forget, when you're all done, make sure you apply the correct sign. The cotangent in the second quadrant, because all seniors, sine and cosecant are positive, everybody else is negative. So this is a negative. So one of these things that you're going to learn in Trig, I think, is don't answer the question or don't think you're done until you're really done. Problem number 52. We want to evaluate each of the following. We're given the cotangent squared of 135 degrees plus the tangent to the fourth of 60 degrees minus the sine to the fourth of 180 degrees. Okay. So 135. What's the reference angle? Second quadrant, 135. To get to 180, 10 minus 5 is 5, 7 minus 3 is 4. So this is a 45-degree reference angle. So we really need the cotangent squared of 45 degrees. Now what I'm also noticing here, these are squares to the fourth power. This is going to make everything positive once we don't even need to worry about that. 60 degrees, tangent to the fourth, 60 is its own reference angle. And 180 degrees is right here. So it's a quadrantal angle, and we should be able to figure that out also for the sine. Okay, so let's go down here and say, what is the cotangent of 45 degrees? Well, guess what? I made one of these. So the cotangent is the cosine over the sine. So it's the square root of 2 over 2 over the square root of 2 over 2 still. So it is 1 squared plus. What is the tangent of 60? So the tangent is a sine over the cosine. 60 is the square root of 3 over 2 over 1/2. So square root of 3 over 2 over 1/2. That's to the fourth power minus. And what is the sine of 180 degrees? Well, that's y over r. Y at this point, this is the point, -1, 0. Y is 0. Doesn't matter what r is. So the sine of 180 is 0 to the fourth power. So this is 1. Before we take this to the fourth power, let's invert square root of 3 over 2 times 2 over 1. 0 to the fourth is just 0. And the 2's cancel, so this is the square root of 3 to the fourth power. So it's 1 plus 3 squared. Right? 9 and 1 is 10. So, it's nice to have around. Number 60. It says determine whether each statement is true or false. And they give us the sine of 2 times 30 degrees is equal to 2 sine of 30 degrees times the cosine of 30 degrees. Okay, so this next line, the sine of 60 degrees is 2 sine of 30. Oh, we can bring this back in. The sine of 30 degrees is 1/2 square root of 1 over 2. The cosine, this is just multiplication, the cosine of 30 degrees is square root of 3 over 2. And let's now, I guess, the sine of 60 degrees is also square root of 3 over 2. Does that equal 2 times, well, let's see. This is the square root of 3 over 4 when you multiply these two together. And this 2 will cancel with one of those. So yes, the square root of 3 over 2 does equal the square root of 3 over 2. It is true. How about number 70? Asks, suppose theta is in 90 to 180. So theta is in the interval from 90 degrees to 180 degrees. In other words, theta is in the second quadrant. What is the cosine of a negative theta? Let's see. So if this is positive theta, a negative theta would be this way. The cosine is negative in the second quadrant. It's also negative in the third quadrant. So the cosine of a negative theta is the same as the cosine of a positive theta. I guess with that picture, here's 1, 2. Hopefully that'll count 2 steps for the person creating that, and it should. We'll have one more here. This is really leading up to another section, but if theta is in the interval from 0 degrees to 360 degrees. Now, this notation is interval notation. This little C-looking thing with a line in the middle. Theta is in, or is an element of, this interval. The square bracket means include that endpoint. The parenthesis means exclude that endpoint. So this is really in the interval from 0 to 360, but don't include the 360 because you already have that with 0. Okay, they want to say find all the values where the cosine of theta is equal to the square root of 3 over 2. So what do you do for these problems? Well, the cosine here is positive. The cosine is going to be positive in a couple of these quadrants. That's true for many of these. First quadrant, cosine is positive. The fourth quadrant, cosine is positive. Remember, all seniors take Cal 4. So these two quadrants are when the cosine is equal to the square root of 3 over 2. Now, for what angle is this true? Well, if we look here and then go to this right side, here's the cosine. Square root of 3 over 2 is right here. If we move up, that's when the cosine, or the theta, is 30 degrees. So we know that theta can be 30 degrees, but you should think of that only as a reference angle. It's true here, 30 degrees, and it's true for this angle, 30 degrees. But we don't want a negative 30 degrees. We want to go all the way around and find the angle that is 30 degrees less than 360. So we want not just 30 degrees, but 330 degrees, which is the 30 degrees less than 360 degrees. So we're finding all the values of theta in that interval. And that you're going to have to do later on. This is your first experience with that. You should be able to do all the problems in section 2.2 in your review exercises.